Alright, so we're going to start with the buff review, the buff colored review, like a beige color. And the first thing it says to do is to identify each conic as a circle, parabola, ellipse, or hyperbola. So before we do that, we don't have to actually get these in standard form. Let's just think about what we know about each one of these and what's going to set them apart. So if it is a circle, I'm going to have an x squared and a y squared type of situation. Now that doesn't mean I couldn't have like x minus 3 or y minus 4 or whatever, but there's no coefficient here, which means that when I divide through so they don't have a coefficient, then I'm also not going to end up with a fraction there. So if there is a coefficient in the general form, then it would have to be the same and they would divide out, but this is also an addition thing right here. For parabola, you're going to have an x squared or a y squared, but not both. For an ellipse, you have the x squared and y squared with different coefficients, and we're adding. Hyperbola, we would be subtracting. Okay? So as we go through these and we look, so this first one right here, here's x squared and y squared, but there's this minus. So the only one that has any subtraction going on is the hyperbola. Here, x squared plus y squared, they have the same coefficient, which is a 1. And so when I finish all this out, I'm not going to have a fraction there anywhere, so I'm going to end up with a circle. Again, I've got x squared and y squared and minus here, so that is going to have to be a hyperbola. Here I have an x squared, but there is no y squared, which means that is a parabola. Here I have x squared and y squared, so we're adding, not a hyperbola. The coefficients are different, so when I divide everything through by 4, it's going to end up with a fraction here. That's going to give me an ellipse. I have x squared, no y squared, so it's a parabola. I have x squared and y squared, coefficients are the same, and it's addition, which means it would be a circle. X squared and y squared, it's addition, so it's not a hyperbola, can't be a parabola because they're both squared, and it can't be a circle because they don't have the same coefficient, which means that this is going to give me an ellipse. Okay, so I didn't really have to do any work there, just had to have an understanding of what was happening. All right, so circles. Just want to identify the center and the radius. So remember, this is x minus h, y minus k, so this is a positive 4, negative 5. Your standard form is x minus h squared plus y minus k squared equals r squared. So this is the radius squared, which means the radius is 4. Center here would give us 1, negative 6. So the radius is the square root of 18, which you are not going to put down as a decimal. That reduces to 3 square root of 2. So here, now I've got this 4. If I divide everything through by 4, this is going to give me x minus 5 squared plus y plus 3 squared equals 2. So my center is at 5, negative 3, and my radius is the square root of 2. All right, so then I'm going to write the equation of these circles. This should be pretty simple since I'm given the center and the radius. Some of you seem to really struggle when you're given the center and a point on the circle, so make sure you know how to do that too. My center is at 0, 0, so this is just x squared plus y squared. And radius is 9, so this is r squared, which is 81. Center, x plus 2 squared plus y plus 3 squared equals, so if I've got to take 3 square root of 2 and square it, I square the 3 and get 9, square the square root of 2 and get 2, so that is 18. Plus, it's the opposite of what we just did there. Alrighty, so now we're going to identify the following aspects of this ellipse. It doesn't ask us to graph it, but if it helps you to, jot some things down, then you absolutely can do that. But for the ellipse, remember the a squared is always the bigger one. It doesn't necessarily have to come first, but the bigger one is the a squared, and whichever one it is in the denominator of, that tells you which direction it's going. So this is going to be a horizontal ellipse because the bigger is under x. The center is going to be at 4, -1. Your A is the square root of 25, which is 5. Your B is the square root of 4, which is 2. C squared for the ellipse, since this is plus, this is C squared equals A squared minus B squared. Okay, so that's going to give me 25 minus 4, which is going to give me square root of 21. Length of the major axis is 2 times A, so it's 10. Minor axis, 2 times B, so it's 4. The vertices, okay, so this is where my A goes with the vertices, and this is horizontal. So remember, if I have 1, 2, 3, 4, -1, there's my center, okay, it is going to be horizontal, so I count from my center 5 on either side because A is 5. So my X is changing, which means that I take my center, I would subtract A, so 4 minus 5 is -1, and I take 4 and I would add 5, so this gives me 9, -1. All right, so then my covertices, take my center point, and I'm using B. And my covertices would be vertical, since this is a horizontal ellipse, which means I'm adding and subtracting from Y. So my covertex, my first one is 4, and I'll take -1 minus 2, which would be -3. And then 4, -1 plus 2, which would give me 1. Then my foci, I'm adding and subtracting C, but make sure that you're adding and subtracting it from the correct coordinate, because that's another thing that some of y'all are mixing up. I'm here at the center, this is horizontal, so my X is what's changing for the C. So I take my X value, which is 4, and I can subtract the square root of 21, and -1, and then 4, and add the square root of 21, and 1. Oh, -1. There you go. We didn't have to actually graph it, but again, jotting something down so you can wrap your mind around what it is. If you want to mark a few points, you can absolutely do that. All right, so I'm going to write the equation. I'll write the equation of the ellipse with the major axis of 14. Okay, so if the major axis is 14, then that means A equals 7. And the foci are 2, 5, and 2, -5. Okay, so I'm going to do a quick little graph here. So I'm going to go to 1, 2, 1, 2, 3, 4, 5, and 2, -5. Okay, so these are my foci. Which means from that, I can find my center point, because I need that in order to write that. So in order to find my center point, I can do the midpoint of these two. So midpoint just means that I'm averaging them. So it'd be 2 plus 2 over 2, and 5 plus a -5 over 2. So this would give me 2, 0. There's my center. You can also do it by counting. I mean, that's why we graphed it, but that's mathematically what's actually happening. So this is my center point. I need that to write my equation. I have that A is 7, and I know C, because this length right here, from the center to my focus, that is my C, and C equals 5. So if A equals 7 and C equals 5, for an ellipse, C squared is equal to A squared minus B squared. So that means 25 is equal to 49 minus B squared. So B squared equals 24, and B is the square root of 24. And I don't need to simplify that, because in my equation I use B squared anyway, and I'm not actually graphing it. If I was actually graphing it, I'd want to simplify it or figure out, my estimate or whatever on there, but I'm not doing that. I just need my equation. And so my equation then is going to be, I've got, this is a vertical ellipse, which means A goes underneath the Y, all right, and my center is at 2, 0, so this is going to be X minus 2 squared, and it's Y minus 0, really just Y squared, My A, which is 7, is the larger one. It goes underneath Y since this is vertical, so this is 49. And then B goes under X, so that's the square root of 24, or I have B squared right there. It's just 24. And there is my equation. All right. So writing this equation in standard form is going to require me to complete the square. All of you understand the basic concept of completing the square. However, some of you are making the same mistakes over and over again, and this is an easy fix. So let's think about what's happening here. So the first thing is I got to kind of move things around. So I'm going to group my stuff together. I'm going to get 9x squared minus 36x plus 4y squared plus 8y equals, I'm going to move that 4 over because I told you to change that 9 to a 4, make that a negative 4. So now I'm going to have to complete the square twice, but I also need to factor this out. So I'm going to take 9 times x squared minus 4x, and then I take half of that and square it, so that's plus 4, plus I factor the 4 out here, 4 times y squared plus 2y, take half of that and square it, plus 1 equals negative 4, and then I have to add 2 things here because I added 2 over here. I added this 4, but there's a multiplier here. So I have to take the 4 times the 9. 4 times 9 is 36, so I'm really adding 36 over here, which means I have to add 36 over here. I added 1 right here, but there's a multiplier, so I have to multiply. 1 times 4 is 4. So then I can go ahead and clean this up. This gives me 9 times x minus 2 squared plus 4 times y plus 1 squared equals, well, negative 4 and 4 cancel out, so you just get that 36. So now I divide through everything by 36. So here, when I reduce this, I get x minus 2 squared over 4 plus y, ooh, that does not look like a y, y plus 1 squared over 9 equals 1. And there's my ellipse. All right, so hyperbolas. Identify the following. Branches open horizontally or vertically. So remember, for a hyperbola, A is always the first one and could be smaller, so it's not always bigger, but this is A squared, this is B squared. Which term comes first, X or Y, tells you if it opens horizontally or vertically. So X comes first, which means they open horizontally. My center is positive 2, positive 3. A is the square root of whatever that first denominator is. So the square root of 16 is 4. B is 2. Here, for a hyperbola to find C, C squared is equal to A squared plus B squared, because A is not always bigger. So this is going to give me, I'm looking for C, so this is 16 plus 4, which is 20. So C is the square root of 20, which I then simplify and don't put a decimal, simplify to 2 square root of 5. Okay. So I can jot this down if it's helpful. I'm going to go to 2, 3. There's my center point, right? I know that it's opening horizontally, which means from the center, I count A left and right to get my vertices. So that means my X value is changing. So I look at my center, and my vertex is coming from A. So I take the 2, I take 2 and I can subtract A. So I can go to the left. That's going to give me a negative 2, 3. And then I can take this and add 4. So this gives me 6, 3. Then the foci, still going horizontally, and so I'm changing the X value. So this is going to be 2 minus 2 square root of 5, 3, and then 2 plus 2 square root of 5, 3. Equations of asymptotes, there's 2 lines, but we can write them all in one. Remember that you take the y term, whatever it is, in this case it is y minus 3, that's equal to plus or minus, and we'll fill that in just a second, times the x term, which is x minus 2. So your slope is always either a over b or b over a. So this a is your horizontal, b is your vertical, and so it's always rise over run, so it's b over a, and b is 2 over a, which is 4, and that reduces to 1/2. And we just took care of both of them in one line. All right, so now I'm going to write the equation of the hyperbola. I have these vertices, so that's 2, 7, and 2, 11. Okay, even if you don't put the little hash marks, you're about there. So that means it is vertical. Since it is vertical, that means when my equation in the end, I'm going to have this. So the first term is your y term, and your second term is your x term, since it is opening vertically. Okay, and then we have a focus at this vertex is at 2, 7, and so this here at 2, 2. This is a focus at 2, 2. Well, I can find my center point. I know my center point has to be right in there. Obviously, for my center, my x value is 2. My y value is halfway between 7 and 11, so 7 plus 11 is 18, divided by 2 is 9. Okay. So I'm there at 2, 9. 2, 9. And I know to get from the center to a vertex, that distance right there is a. So a is 2 to get from 9 to 2. So a equals 2. I know to get from the center to the focus is c. So from 9 to 2, that is 7. So c is equal to 7. In order to write my equation, I know that a always comes first. So a squared, that denominator is 4. I can go ahead and get my numerators in there because I have the center point. Remember, it's opening vertically, so y comes first. So this is going to be y minus 9 squared, and then x minus 2 squared. So this denominator is b squared. That's what I'm missing right now, so I've got to go figure that out. And so for a hyperbola, c squared is equal to a squared plus b squared. So that means that 49 is equal to 4 plus b squared. So b squared equals 45. I don't really care about b because I'm not graphing this. I just need b squared, and I've got that. It is 45. There is my equation. So if I'm going to change standard form to general form, that just means that I have got to multiply everything out, basically. I can start by getting rid of the fractions. So to get rid of the fractions, I'm going to multiply everything by 3, everything through by 3, and everything through by 4. So basically by 12. But really, if you think about multiplying it through by 3 times 4, which is 12, 3 times 4, again, which is 12, then the 3's cancel out, so you just end up with a 4 out front, and the 4's cancel out, so you just end up with a 3 out front. You multiply the 1 times 3 times 4 also. That'll get you the 12. So if I do all that, then I'm going to end up here with 4 times x plus 4 squared plus 3 times y minus 3 squared equals 12. Okay, so I just cleared the fractions basically. This gives me 4 times, then when I square this, that gives me x squared plus 8x plus 16 plus 3 times y squared minus 6y plus 9 equals 12. Then I'm going to distribute, and I get 4x squared plus 32x plus 64 plus 3y squared minus 18y plus 27 equals 12. So then, to get it in general form, my x squared comes first, 4x squared, then my y squared plus 3y squared, then my x to the first plus 3x, not 3x, sorry, 32x. 32x, then my y to the first minus 18y, and then I've got positive 27, positive 64, and then this, when I move the 12 over, it's going to be negative. So that's, just write it here so you understand what I'm saying. Basically, I'm going to get 64 plus 27 minus 12. 12. So that's going to be like 64 plus 15. That's going to give me 79. That's a positive 79 equals 0. There is my general form. It's the opposite of completing the square. You're just undoing it. All right, so now we're going to graph each one of these. It says to use graph paper. So, all right, let's see, I have graph paper here. So this first thing, you want to know what the thing is that you're graphing first of all, and this looks to be a circle. So to graph my circle, I need a center, which in this case would be 2, negative 1, and the radius, which is 3. And that's really all I need. So I'm going to draw in an x and y axis here. I think that's big enough. So I go to plot my point. My center point is at 2, negative 1, and my radius is 3. So from this point, I count to the right 3, go back to the center, up 3, go back to the center, to the left 3, center, down 3. And I'm going to sketch that in. There's my circle. That's a pretty good circle. All right. Then here, I've got the x squared and the y squared, different denominators, so it's not a circle. This is addition, so it's not a hyperbola. This is an ellipse. So in order to figure that out, I need A, B, and C, and I need the center point. So my center here is negative 4, 3. Okay, so for an ellipse, A is always the bigger one, so this is A squared, which means A is 4, B is 2, right? C is going to be C squared equals A squared minus B squared. If this is addition, this is subtraction. So C squared is going to equal 16 minus 4. So C is the square root of 12, which is 2 square root of 3. Okay. So then I need the focal chord length. Okay, so your focal chord length, because this is something some of y'all still aren't plotting, and you need to plot these points. It is 2b squared over a. So that's going to give me 2 times 4 over 4. So my focal chord length is 2. All right, so now to graph this, I'm going to get my grid in here. Make it long enough. Okay. So I'm going to plot my center point. I'm going to go to negative 4. 1, 2, 3, 4. 1, 2, 3. And that is my center. So from that, I'm going to need to plot, count, and get A, and decide that if I'm going to count, am I going to count vertically or horizontally? Well, A is underneath the Y, which means it is a vertical ellipse. So from the center, when I count 1, 2, 3, 4, this gives me a vertex. 1, 2, 3, 4, this gives me a vertex. Okay. My co-vertices, that's where B comes from, so I go 1, 2, and 1, 2. I need my focus point. So my focus, the C is 2 square root of 3. That's the distance from the center. Here's where I estimate it. Notice my answer is in exact form. The decimal approximation, which you either get from the calculator or you should be able to approximate some of these. Not necessarily all of them, but the square root of 3 you should know is about 1.7. So this is about 3.4. Any more accurate than that doesn't really matter on graph paper like this. So we're going to go from the center, 1, 2, 3.4. 1, 2, 3.4. Right about there. And then from that, so this is my focus. I just realized I made it the same color as the axis. My focus point. Right. The points that some of y'all continue to leave off. And I took the blame the first time because the first day of this, I don't know that I made it real clear. But the second day, I know I did, and I know that I have since then. That focal chord length gets you other points that you have to have plotted to get your ellipse. Quit giving me these sad little pictures where you don't even plot the points. And I need to be able to tell that you plotted them. They don't have to be ginormous, but they can't be so tiny that I can't even tell what you draw over it. My focal chord length is 2, which means from that focus point, I go half of that, which is just 1 on each side. These 2 points are points that are on my ellipse that is going to help me get to the shape that I need. So now that I have all of that, then I can sketch this in like so. Ugh. Pen doesn't hit exactly where I want it to. Something like that. It probably would have been better if I dotted it, but it doesn't have to be dotted, but the dotted sometimes does help you get it, hit the points a little bit better, especially when your pen isn't calibrated right. All right, so there you go. Now the next one is subtraction here. So this is my hyperbola. I still need A, B, and C. I still need the center, and I still need my focal chord length. All of those things are important. Okay. Plus I'm going to need asymptotes, which you don't really have to write the equations of them necessarily, but you do need to be able to figure out where they are. And that's pretty, I'm sorry, let me say that. You do need to be able to write the equations of them. You just don't have to write it on this one. So let me get my axes in here. So my center point is going to be 2, 0. Your A on a hyperbola is the first one, not necessarily the bigger one. So A is 2, B is 3. To find C on this one, here C squared is equal to A squared plus B squared. So this is 4 plus 9. So C is the square root of 13. So square root of 13 you should know is somewhere between 3 and 4, a little bit closer to 4. My answer for C is actually the square root of 13. If I had to write down ordered pairs, I would use the square root of 13, but it is about 3.6 just for graphing purposes. All right, then my focal chord length, which I also need, is still 2b squared over A. So that's going to be 2 times 9 over 2, which is 9. So let's start plotting. My center point is at 2, 0. There is my center. From that, I need to find, well, first of all, I need to figure out, am I opening up and down or left and right? Since my x comes first, doesn't matter about the denominator, which one's bigger. X comes first. It has a horizontal transverse axis, so it's opening left and right. And so from the center, I go A to the right, 1, 2. That's my vertex. Left, 1, 2. That's another vertex. B, 1, 2, 3, that's a covertex, 1, 2, 3, that's another covertex. Now, I need to get in my asymptotes. So there's this rectangle here, which you can draw in the rectangle if you want, but sometimes that's a little bit too much. You just at least need to get the corners of the rectangle, which is really, really easy to do once you have the vertices and covertices on there. So then you just dot your lines. I'm not going to dot mine because when I do that on here and my pin's all off, if I'm off on my line, it just does not come out very well. So instead, I'm going to draw this in, but if you're using a straight edge, which is really hard for me to do up here, but I would suggest that you do maybe make them dotted or do a different color or something like that so that you can tell what's going on with them. Okay, so there are my asymptotes. Just like so. All right, so I have the vertices, I have my asymptotes, I know that it's opening left and right, so I don't draw them wrong. I'll be real honest with you, I've told myself when I start a lot of these, I know exactly how they're supposed to open and what they're supposed to do, and I still, because I didn't label this stuff, will make them go the wrong way, and then I'm confused because things don't work out. But here's what, everything's good so far. Now I need to go in here and I need to graph my focal points and the endpoints of the focal chord. So from the center, the C gets me to the focus. So it's about 3.6. So go 1, 2, 3.6. That's a focus. From the center, 1, 2, 3.6. That's another focus. Okay, so the endpoints of my focal chord, you have to plot these points. The focal chord length is 9, which means I go 4.5 on each side. So 1, 2, 3, 4.5-ish. 1, 2, 3, 4.5-ish. 1, 2, 3, 4.5. Okay, so it's really close to the asymptote, which is what was happening the other day, but my asymptotes were so bad I thought I was doing something wrong. So now when I come in to graph this, go from the vertex through that point and goes up against my asymptote. Remember to make sure it doesn't like curve back in because that's why we have an asymptote there. Looks something like, oh, see that one curve back in. There we go. And there you go. Not too bad. Okay, and then the other review will be in a different video.